Pick up your phone, check the time. Now imagine that number slowly, quietly, getting less accurate every single year. Not because your phone is broken, because the day itself is changing. You've always assumed a day is exactly 24 hours, fixed, forever. It isn't. And the reason is something hanging in the sky right now, pulling at you in a way you've never noticed. Let's start simple. The moon doesn't just sit there, it pulls on the Earth. You can see proof of that pull every time you watch the ocean. Tides rise and fall because the moon's gravity tugs on the water, stretching it slightly toward itself. But here's what almost nobody thinks about. The moon isn't only pulling on water, it's pulling on the entire planet, including the ground spinning beneath your feet right now. That pull acts like a brake, a very, very slow one. Every single day, the Earth's spin loses an almost invisible amount of speed. We're talking about milliseconds spread out over centuries. You'd never feel it in a lifetime. But it's real, and it's measured. Here's the strange part. As the Earth slows down, the moon doesn't stay still either. It drifts away. Right now, it's moving farther from Earth at about the speed your fingernails grow. Slow. But it never stops. Scientists have measured this directly, using mirrors astronauts left on the moon decades ago. Bounce a laser off them, time how long the light takes to return, and you get the exact distance. Every year, that distance grows by a few centimeters. So picture it, a slowing Earth, a drifting moon, and somewhere in the middle, your day, quietly stretching. Hundreds of millions of years ago, a day on Earth wasn't 24 hours. It was closer to 22 hours, sometimes even shorter. Dinosaurs didn't experience the same length of day you do. Their sun rose and set faster. Push it back even further, to when the moon had just formed, and a day on Earth may have lasted only a few hours. A few hours. Spin, sunrise, sunset, all within the time it takes you to watch one movie. Now, flip it forward instead of backward. If the moon keeps drifting away and Earth keeps slowing down, future days will stretch even longer than they are now. Not dramatically. Not within your lifetime or your children's or many generations after that. But the direction is locked in. Here's where it gets genuinely strange, though. You'd expect the slowdown to be smooth and predictable. It isn't. In recent years, scientists recorded some of the shortest days ever measured, spinning faster than expected, not slower. Nobody fully agrees on why. Theories point to shifting ocean currents, melting ice, changing the planet's mass distribution, even motion deep in Earth's molten core. So, the long-term story is clear. The moon is slowing us down, stretching our days, one almost nothing fraction of a second at a time. But the short-term story keeps surprising the people measuring it. Think about what that means for something as basic as a clock. Every few years, scientists have to add a leap second to global timekeeping just to keep clocks in sync with the planet's actual, ever so slightly inconsistent spin. Time isn't some fixed, unshakable thing ticking in the background of the universe. It's tied to a planet that wobbles, slows, and occasionally speeds up, shaped by a moon that's been quietly drifting away since before anything alive existed to notice. So, the next time you glance at a clock, remember this. That number isn't permanent. It's borrowed, season by season, from a slow tug-of-war between Earth and the moon that's been running for over 4 billion years. And it's still running right now, underneath every second you spend reading this.